Sound check. All right. I don't think this will take too long. I'm compiling a list of standards and specifications for everyone. I'm getting a lot of comments asking about the accuracy of the equipment, what the expectation is, how to perform the work, and so forth. And it's not easy to answer all those questions in the comments. So what I've done here is compiled a full, it's not a full list, it's a partial list, but it's a lot of information to get started with. So the first thing that I'm showing you is a study that was done of the wild T2 theodolite. I have a PDF linked where you can download this and read the expectation of how this instrument performs. So I'm starting with that. Next is the currently used standards for positioning. Here's page 2-3, where the work is described positionally in terms of its accuracy, and you can specify a horizontal accuracy and a vertical accuracy. You can specify them to be both 1 centimeter, for example, or you could say the work that we're going to do on this project needs to achieve a 2 centimeter horizontal accuracy standard and a 2 millimeter vertical accuracy standard. It's just an example. Of course, the accuracy that you specify will dictate the type of equipment used or required to be used to achieve those accuracies, and these are quoted at a 95% confidence level. So again, the link to the PDF of this document is in the it's not in the description box. It has to be in a pinned comment because it's a very long list. If you're interested in the historical accuracy standards and specifications that were used during the days of triangulation, I've given you this link, and at that link you can actually download a PDF version of this document. Here's the table of contents. If you have any interest in learning how triangulation was performed, traverse, geodetic leveling, etc., it's all in this document, along with lots of other information. Okay, speaking of accuracy and precision, etc., I've included this really nice book. What's the date on this one? This is back to 95. Washington Department of Natural Resources, Public Land Survey Office, and Survey Advisory Board. This is the Surveyor's Guidebook on Relative Accuracy. You'd be surprised the wealth of information that's out there, put out by different agencies, different states. Of course, every state Department of Transportation, that would be called your DOT, let's say, they all have their own accuracy standards and manuals on how to perform survey work for the highway departments in those states. But here's an example of a book discussing accuracy. Here's the table of contents, going through the statistics involved in computing your results. Did you achieve? This is a way of determining that you did achieve the accuracy specification for a certain project. Keep in mind, depending upon what work you're doing, you're not going to go through the expense of, let's say, doing first order leveling for a project that say a half a foot might be adequate, or 1/10 of a foot might be adequate. So it always goes back to, what are we doing? What is the nature of this work? What is it going to be used for? That will dictate your level of accuracy required to perform that work, which then goes back to helping you decide what types of equipment to use and the methods and procedures you'll follow. One of the last pages of that book has a nice graphic helping you visualize three-dimensional positional tolerance, or what you could call the uncertainty in that position. And it ends up being a repeatable thing. In other words, if you've done the work at a 95% confidence inside a certain band, that's saying that 95 times out of 100, if you go back and measure that point again, you should be plus or minus that amount. Okay, that's what this does. So let's see, the next thing I'm going to talk about a little bit here are coordinate systems. And here's the manual on state plane coordinates of 1983. Again, the link is in the list. I've also linked this book, which is a discussion on the history of the state plane coordinate system and the future, because we are coming up on a new datum change slated for 2022, I believe. You can read about that in this book. And just keeping with coordinate systems and mapping projections, this is the book that will tell you all about the different kinds of mapping projections that are used for different purposes. Depends upon what you're trying to do, what region of the world you're trying to display. You'd look at this book to decide what type of mapping projection to use to get that done. What would be well suited for that. This is a scary book filled with, very scary looking mathematics. If you're interested in triangulation, I've given you the links to the manual of reconnaissance. In other words, all the planning that goes into selecting where to put the stations. Will they be intervisible or not? You have to figure these things out based on the terrain, etc. So this is a book that talks about how triangulation parties would go out to do the reconnaissance to plan their triangulation scheme. This is the manual of geodetic triangulation that pretty much lays out how the entire triangulation party will operate, from observers to node keepers to those who are computing and all the other tasks associated with moving this large amount of people and equipment across a countryside doing triangulation. It's a thing of the past and pretty cool. And then here's the manual on computing the results of all those observations and adjusting that work to produce the actual positions. A lot of people aren't aware of this, how triangulation was performed from the tops of towers. If you were in the mountainous states, obviously, you may come across these brass discs set in the rock up on top of mountains. So from one mountaintop to another, you can see pretty far and you can make those observations. But in the lower lands where it's flatter through Kansas, pretty much the Midwest, etc., all the way over here to the East Coast, all up and down the East Coast, triangulation was performed from the tops of these towers, and they're named after the guy, his name was Bilby, who came up with this tower. There was an inner tower that the instrument occupied and an outer tower that supported the observers. And this tower was inside of this tower. That way, when they were walking around up here, this thing's moving, the instrument would not be disturbed. So you could think of this as like a really gigantic, tall surveying tripod situated right over top of the monument, the disc. And here's one. Here's a 90-foot Bilby steel tower complete. So you could see there's a platform here to walk around, and an inner tower in there where the instrument would go on top of. And a light keeper would be situated here, aiming lights toward the other observers that could be 10, 20, 30, 40, 50 miles away, doing that triangulation. Here's just another view of the inner and outer towers. There's the ladder that they would climb up to get up on there. Here's a neat picture of the light keeper. He's looking with his binoculars, trying to find the other tower that he needs to rotate and aim this bank of lights toward. And you could well imagine that there would be anywhere between 6 to 10 or more of these towers erected out in the distance as they moved along, observing these quadrilaterals and triangles of triangulation. Here's the observing party. So speaking of triangulation, this is a pretty amazing book talking about the transcontinental triangulation in the American arc of the parallel. This was published in 1900. It's about 3 inches thick. I managed to get a copy of it. I found it from a used book trader. It was in France, and I paid very little for it, and I'm very happy to have it. Here's a map showing you this transcontinental arc of triangulation that they measured across the country from Cape May, New Jersey, all the way over to Northern California. So if you're interested in looking at maps depicting this survey work, you can come to this website where I've provided the link. Tell you what, I'm going to take a glance over in the chat just to make sure I'm actually being heard. And no one's saying anything, but I've got 4 viewers. Hello all. I'm just checking because sometimes I forget to turn something on like my screen, and I come over here and people say, we can't see anything. Anyway, continuing on, I've given you this link, and let's just say you had an interest in looking up some control diagrams over near Denver. You could come here, click on this, and it would bring up a PDF of the triangulation, not only the triangulation, but also the leveling. The leveling is going to be shown here. And sometimes you'll see traverse lines as well. It also differentiates the different agencies that made these observations. The red is usually going to be the USGS, that's the US Geological Survey. And then the black ones are usually what was formerly called the Coast and Geodetic Survey, now called NGS, National Geodetic Survey. So there's some history here on how these maps were made to show the actual survey observations that were made over many, many decades. Here's another great source for old historical diagrams and maps. Zena's survey station. It's in the. I linked it in the list, and so you can come here to this site and say you want to look up the actual triangulation diagram for the state of Colorado. This is where you would find it. And let's not forget about the leveling. I kind of focus on the horizontal mostly, the old triangulation, but there was a lot of leveling done, and leveling is a slow and tedious process to accomplish. So you're seeing all the lines of leveling that were run over a long period of time in Colorado. You can get one of these for every state. Now, if you're interested in finding the marks, let's just say you want to find one of these old triangulation stations or traverse points or leveling benchmarks. Like every one of these, every so far, there's one of these discs set in a substantial rock outcrop or something like that. There's all different marks. There could be rivets. There's different types of marks you could find. And if you want to find them, you would just come to this website, and I've linked it for you, where you can actually set a radius and have it do a search for you. And then you can click on a mark and bring up what type of mark it is. There's all different types. Some are horizontal only with a scaled vertical position. Some are very precise vertical benchmarks, and their horizontal position might just be scaled from a map. This one is both. So you'd click on Data Sheet, and it brings up the data sheet that you can just copy. It's absolutely just ASCII text. You can use Notepad to look at it. But it's going to give you all the positioning data and its history. I don't show you that, but down below is who set it, when they set it, the different years it was recovered, and so forth. So that's all there for you. Also, you could download this app on your phone called Benchmap. So let's just say I was coming out here to Colorado. I wanted to look up some survey control marks in the area. I could do it right on my phone. For instance, here is the northeast corner of Colorado, where it borders Nebraska. There's actually a mark set here, and I can look up the data sheet right on my phone to get the information. So the coordinates are here in latitude and longitude. You also have the Earth-centered, Earth-fixed X, Y, and Z position, which is obtained by GPS. And the position is published at these accuracy standards, 0.16 centimeters at a 95% confidence. So I refer you back to the other books on the list discussing positional accuracy. You can learn all about that. But it's there. It's basically everything you'd want to know about that survey marker. Now, speaking of land boundary corners, especially out west, I've included links to the Bureau of Land Management manual. This is the 2009 edition. These go back in time, back to the 70s and also back into the 1800s, containing the instructions on how to lay out these townships and ranges and so forth. So that's there for you. I've also included the glossary of terms so that you would understand what they call certain types of marks, certain types of reference marks, etc. That's there. This is an interesting book on the restoration of lost or obliterated corners. And this is a map of the United States showing you where that type of surveying is done. It's mostly all these rectangular states. It's called the rectangular system. Over here in the east where I work and live and work, we are a part of what's called the colonial states. Our surveying is meets and bounds descriptions. Very haphazard, very, no rhyme or reason to it. Over here, they try to adhere to trying to keep things as rectangular as possible. You're not always going to have that, especially if you're bordering a river or something like that. But in general, these are laid out rectangularly. Let's continue here. These are just some pages right out of the book. Here's how they lay out these townships and ranges and sections. I have never done this myself. I don't have a license to survey in these states, and my familiarity with it is simply knowing a bit about surveying, that this is how it's done over here in the West. This is an interesting website talking about where some of these corners come together and why. And of course, it's because these north-south lines are converging, you see. So the distance across the bottom of a state or township, this distance is going to be larger than this distance because these lines are literally converging as you go northward. And so you find these situations. And this person wrote this article and includes some photography of these areas where these townships and ranges come together, and you know, stating why. So one of the things that interested me is the fact that there is such a thing as a solar compass. I've never used one, but I've read about these. And you can read right here from the book that I just showed you how they abandoned the use of the magnetic compass because of the fact that that magnetic needle would be affected by different material in the earth and would throw off your bearings. They began to use an attachment or a thing called a solar compass, which would keep them on a true north-south line. And they could actually rely on the sun to help them with determining those directions. So here's a drawing of a solar compass. Interesting. And I've linked to some sources for these. Here's a picture of one. There's actually a nice website that talks all about solar compasses, and a book. I think it's just called Solar Compasses. So here's a schematic of what's called a solar attachment for a transit. So here's the solar attachment for transit instruments. Pretty neat looking instrument. So here's your normal surveying transit, and this is the solar attachment. Which brings me to this. Just the other day, I've been wanting to do this for a long time, but this is my next phase of rekindling old practices. And I used to do lots of solar observations with this T2 back in the 80s. And now I just went out last week and made a little live stream of me actually making these observations. So there's more to come. I'll be talking more about how the azimuth is determined from your angles measured to the sun, and also Polaris. So I'm going to do some Polaris observations. Here's a book I linked for you talking about how we make these computations. It's a nice basic book on azimuth determination by celestial observation, not only solar, but also Polaris. Okay, now, not to be too US centric, because I tend to be, if you have an interest in, let's say, the Himalaya Mountains, Asia, this is a great website. It's in the links, it's in the list, where you can come and find a huge list of books on geodesy. And this is where you can download this book I talk about a lot. It's a nice starting book to get involved, to learn about how the curvature of the Earth was measured by lots and lots of people over a long period of time. And, you know, it's there for you. The other thing there is, let's say you're interested in the survey of India. You could come here and look at all the work done by lots of people through time, throughout history. And if you'd be interested in learning about, let's say, how they established the elevations of the Himalayan mountains, you could find that information here. The Great Trigonometrical Survey of India. Here's the map of the northern portion of that triangulation through India. And here's all the sight lines they observed to do the intersection computations of horizontal and vertical angles to establish the elevations of these mountain peaks. And I think I'm wrapping this up here shortly, ending on refraction. I've given some references to studies of refraction, This is a good article on determining refraction from reciprocal zenith angles, real high-end type stuff. I think I close out with a link to Walter Bislin's refraction page, where you can literally learn about refraction. I've seen no other better source for this information. He's collated together lots and lots of information on refraction, presented it in a really understandable way, and provides a model where you can play with it, increasing the temperature, watching the effects of refraction due to changes in temperature and pressure. So that is it. I think I'm going to end it here. I wanted to just provide the full list for people to refer to, and hopefully people that are interested in this will find this. It's a starting list, let's say. I mean, it's new stuff, but it's old stuff. It's the history plus some of the current references. And I think what I'll do next will be a list of all current information. That's it. I'll say have a good day, everybody.